Hi everyone, this is Jim Martinez once again with the 8th grade science channel, and today we're going to be learning about arranging electrons in the atomic structure. So today concept is going to be very easy. Let's just keep the alignments with our ticks, which is 8.5a, to describe the structure of the atoms, including their masses, electrical charges, and location of protons and neutrons inside the nucleus and electrons on the electron cloud. From previous knowledge, we have learned a couple of things like the parts of the atom, which includes the nucleus and the electron clouds. Also, characteristics of subatomic particles and their locations, like protons that are positive, neutrons that have no charge, and both of these are actually located inside the nucleus of the atom, and then the electrons floating around on the electron cloud. The meaning of the atomic number, we also learned that. We know that the atomic number represents the number of protons and electrons. And we also have learned to identify and determine the atomic mass of an atom by adding protons and neutrons in the nucleus of the atom. So let's get started. First of all, we need to know what are the electrons. Okay? Well, the electrons are very small subatomic particles that move randomly. They actually have no pattern. It's impossible to predict where they're going to be moving around the nucleus of the atoms. How small are they? Well, they are very, very small, right? I'll let you read that. All right, get it? They're smaller than me, so they're small. Protons have about 2,000 times more mass than electrons, so that you can have an idea how big they are. Okay, protons are about 2,000 times more massive. Okay, in times or in terms of size, it's actually not appropriate to say that they're a certain size because we don't know the size, but we know that they're very massive. I mean, the protons are very, very massive compared to the electrons, so they're 2,000 times more. Electrons are roughly one of almost 1835 in mass compared to protons. So as you can see, this is almost 2000, right? So almost one thousand. I'm sorry, 1/2000th of a mass. They have negative charge. We know that because electrons, we have seen it before, the characteristics, and we know that they have a negative charge. They are attracted to the nucleus of the atom due to the polarity. All right, so they are always going to be floating around the nucleus of the atom because you know the positive and negatives kind of like attract each other and they don't want to split from each other. How to arrange electrons in atoms? We got to know a couple of rules before we get started. Okay, first of all, the first energy level can have 1 or 2 electrons. Okay, so that is very easy. We can actually put an energy level here, and this will be acceptable if we have only one electron, and this will also be acceptable because according to this rule we can have 1 or 2 electrons on the first energy level. The second energy level can have up to 8 electrons. If you notice, we're not even worrying about the nucleus of the atom. Right now, we're just doing the electron cloud or energy levels. So according to this one, the second energy level, we can have up to 8 electrons. And the word up to, that means we can have 1. Yes, it's possible to have 1. All right. Remember, it's up to 8. So we can have 2. Yes, that is also possible. So we can have any number in between 1 to 8. So all this is possible right here on the second energy level. And if we go to the next energy level, it's pretty much going to be the same rule as the second one. We can have another energy level, and we can have up to 8 electrons on this third energy level. And that is a good looking electron cloud. Yes, sir. Okay, so those are the rules. Now, those were easy rules. Now let's take a look at the relevance of the periodic table to this. How is this relevant? Well, you have seen this part. This is like the first a couple of columns inside the periodic table, and we have seen these ones before. We have talked about this number on the top. We have talked about this number on the bottom. Remember, this is the atomic mass, and this is the atomic number. And this is the one that we're actually going to be paying attention to that number on the top. So we know that the atomic number of an element actually determines the amount of electrons in an atom. So here we have the first column of the periodic table, a bunch of different elements. All of these ones have the atomic number, and remember, the atomic number determines the amount of electrons and also protons. But right now we are going to be arranging electrons, so we really don't care about the protons, right? So let's get started. Why don't we practice? I know it's your favorite stuff to do, so let's practice. Here we have helium. Helium has an atomic number 2. So what do we do? According to the rule, in the first energy level, we can have 1 or 2 electrons. And since helium has 2 electrons, or the atomic number is 2, that means we have 2 electrons. All right, so that's it. We arrange them in the first energy level. And yes, if we put the protons, well, then gonna put them inside. And since this is 4, the mass is 4, that means we have 2 neutrons. But like I said, we're not gonna worry about the nucleus of the atom right now. This is lithium. Lithium, the atomic number is 3. So if we put one energy level over here, we put 2 electrons on the first energy level, but we're still missing 1. So what do? We cannot put another electron because that will just not be possible. This violating the rules. So instead, we put another beautiful energy level, and then we add that electron that we're missing. So now we have 3 electrons. This is very easy, right? All right, so I'll clap for you guys. Here we go. Yes, sir. Let's go to the next one. This is carbon. Now, carbon has an atomic number of 6. So if the atomic number is 6, that means we have 6 electrons. Right? So that's going to be very easy. Papita. Piece of cake. We put 1 energy level. We put 2 electrons. And then, obviously, we need 4 more because we need 6. So we're going to put 2 over here on the top and 2 more on the bottom. Now the next element, I don't know if it's going to show up because the camera is right here, but let me try. Awesome. It did not show up. So what we have here, I'm just going to put them on the top. All right, what we have here is this. Oh my God, that is a nice square, don't you think? Yes, it is. And this is what we have in there, but we just can't see it because my awesome face is right here on the way. So what we're going to do is we're going to be looking at this one, which is the atomic number, and we are going to be creating this atomic structure over here on the top. We need 10 electrons, obviously. The atomic number is 10, right? So we are going to put 1 energy level, and we're going to put 2 electrons here. We need to put another energy level because we need 10. So we have 2 so far. And this is 3, 4, 5, 6, 7, 8, 9, and 10. And you notice that this energy level is full? Just like this one over here was full because you cannot possibly put another energy level. Another electron. The same situation happened on this one. We have all the 2 energy levels are completely full with electrons. We have one more. This one is a little bigger. Okay. We are going to be putting the atomic number here is 11. So remember, this is 11 electrons. So here we are going to put the first energy level. We're going to put 2 electrons. We need 9 more, right? So we put another energy level. We put How many can we put on the second energy level? According to the second rule, we can put 8. So there you go. We have 8 around this energy level, and then we have 2 more. So that's a total of 10. Now, we need 11. We don't need 10. We need 11. So what do? Now, here's the problem. So, well, actually, it's not a problem because all we have to do is put another chancla. I'm sorry, that kind of looks like a chancla, but it's another energy level. Okay, and we add one more, and now we have 11 electrons. So you see how easy this is, and we can actually put a happy face here if you want. All right, let's go to the next one. This is chlorine. Now, whoa, chlorine has a big number over here. Well, pues ni modo, we have to do the actual work. So here we go. We're gonna put the first 2 electrons on the first energy level. All right, we need how many more? About 15 more. Okay, so here we go. We put 8 more on the second energy level, right? So far we have 10. Okay, we need 17, remember, not 10. So we put another energy level over here, and we're missing 7 more. So I'm gonna put 2, 4, 6, and then 1 more, and that is 17. If you still have any questions and you're still in doubt on how to do this, you can just go back and look at the video again. And once you look at the video, you're going to realize how awesome Mr. Martinez is. All right? Well, that's not exactly what we're supposed to hear. All right? So let's go and let's review everything that we have learned today. First of all, we learned the electrons are arranged in energy levels. Do you remember that? Of course you remember. Let's go to the next one. The atomic number of an element determines the amount of electrons of an atom. Remember that? The atomic number is that little number on top of the symbol. That tells you how many electrons you are going to have inside, I mean not inside, but around the nucleus of the atom. Remember this one. The first energy level can have 1 or 2 electrons. This is the first energy level. The second one can have up to, there's the keyword there, up to 8. It can have 1, 2, 3, 4, 5, 6, and 7, up to 8. And the last one is the third energy level that can also have up to 8 electrons. And, well, you know, in middle school, you don't have to worry about anything beyond this point, okay? We're going to leave something for your high school teachers so they can explain further. Or if you happen to take chemistry, or if you just happen to go into a science career. All right, so that's it. This is Gilbert Martinez once again with the 8th grade science channel. Thank you for watching. I'll see you later.